Graphing piecewise functions, part 1. We're going to graph the piecewise function f of x equals 2x plus 3 on the interval x is less than 2, and the expression 3x, negative 3x plus 1 on the interval x is greater than or equal to 2. So the first thing that we're going to do is divide this graph into two pieces. And we're going to divide it at x equals 2. So at x equals 2, I'm going to draw a dashed line. On the left side of that x equals 2, this x equals 2, we're going to graph the function, the expression 2x plus 3. We're going to graph 2x plus 3 on the left side of that x equals 2 because x is less than 2. So the x values, the domain that we're going to substitute in for this x, only exist on the interval x less than 2 for the expression 2x plus 3. On the right side, we're going to graph negative 3x plus 1. Because the domain, the x values for that expression are all the x values greater than or equal to 2. So on the left side, we're going to take this 2x plus 3 and we're going to find two ordered pairs. So I'm going to choose two x values. And the x values I choose, as long as they're less than 2, it makes no difference. So I'm going to use 0 and negative 2. So then I substitute the 0 in for the x. 2 times 0 plus 3. So when x is 0, y is 3, which gives us the ordered pairs 0, 3. There's our x, there's our y. When x is negative 2, negative 4 plus 3 is negative 1. So when x is negative 2, y is negative 1. Now I plot those 2 points on my xy axis. So when x is 0, y is 3. So that's 0, 3. I label that point. When x is negative 2, y is negative 1. I label that point. Then I take a straight edge and through those 2 points, starting at x equals 2, I draw a line through those 2 points. Now, at x equals 2, I draw an open dot. Open because x is just less than 2. Now on the right side, negative 3x plus 1. We're going to choose 2 points. I'm going to choose 2, x equals 2, as a point because x is greater than or equal to. Because of the equal to, I can use 2. So I'm going to use 2 and 3. So I have negative 3 times 2 plus 1. I substitute the 2 into that expression. So I get negative 6 plus 1, which is negative 5. So my ordered pair is 2, negative 5. Then I substitute the 3. Get the expression right. So it's negative 3, substituted 3 in for the x plus 1. So it's negative 9 plus 1, which is negative 8. So I have 3, negative 8. Now I plot those 2 points. 2, negative 5. So when x is 2, y is negative 5. That's a solid dot at 2 because of the x is greater than or equal to the 2. And then at 3, when x is 3, y is negative 8. I label that point. Take a straight edge. And there's the line representing negative 3x plus 1. So there you have the piecewise function 2x plus 3 on the interval x less than 2, and negative 3x plus 1 on the interval x greater than or equal to 2.